Hello, I'm Miriah Peterson, and I'm really excited to speak to you today at this Site Reliability Engineering session of Conf42. I am currently a member of technical staff at Tailscale, and we will be talking today on the topic of data reliability engineering and why it's crucial to your data organization. So we'll start with what is data reliability engineering. Just as Google's published SRE practices have been implemented and re-implemented across various software engineering organizations, implementing these same practices to data organizations and data engineering to your data services is data reliability engineering. We implement these practices with the focus of decreasing downtime and improving client experience or the experience of data users and data practitioners. So main key topics are finding if your data is reliable, decreasing your data downtime, utilizing data level metrics, and increasing or creating a platform for data observability. Reliable data is a little bit different than what you would say for a reliable web service. There are many aspects to reliable data. They include accuracy, freshness, missing data duplication, but they also include the latency at which data is available. If you can access data, it depends on the databases, the data stores, the data gateways, and you want to be able to maintain a first class or a 4959 experience for all of these aspects of your data. Additionally, when you're building systems for reliable data, you have to understand that systems are not perfect. That's why we're not aiming for 100% systems. We do want to create budgets that allow for failure, and that by leveraging these budgets, we have a first-class team that understands what a data incident is and can respond quickly, right? So that we have a cushion for intervention, we can respond quickly, efficiently, so that the customers don't notice large outages, that we have minimized our downtime, and we have created an experience that says this data is reliable, and we are willing to create, that first-class experience. Data downtime, like I said, can have various parts to it. Bar Moses, the CEO of Monte Carlo, which is a data observability platform, has long proliferated this definition where it's not just your data being unavailable, but if your data is erroneous, if it's only part of the picture, if it's inaccurate in any way, that is data downtime. And that's what we're trying to, in an iterative way, leverage signals and metrics, our error budgets, and our engineering time to minimize that, to make our data as reliable, as close to the customer's the practitioner's expectation as possible. Things we can do, just like with service level metrics, you can put metrics at a data level to capture the stability of your data pipelines, of your data stores, of your data gateways, or other data services. You can create pictures of if your queries on data stores are taking too long, if you're taking too long to train a model, if your data gateway has an unexpected latency or is returning an inappropriate error. You can use all of these informations put together to create a picture and explain visually, through metrics and other metadata, if your data is reliable, and, through anomalies, create alerts that allow us to investigate them. Like I said, we can investigate latency, see which is our most traffic services, which services are experiencing more or less traffic than we've expect if we have error messages being thrown when they shouldn't be, or serving 400 errors, 500 errors on API gateways. Maybe you're having a saturation on your gateway or on your database or on other data store you don't expect. These 4 things are part of the golden signals expected out of the SRE handbook. Observability is one step beyond those metrics. We take these metrics and create SLAs, SLIs, and SLOs to make sure that our data services are performing to what your data practitioner needs. That way, as things come up, right, we have our metrics are reporting something unexpected. Through those SLOs and SLIs, we can address that either immediately, depending on the criticality of that error. We can throw it into a bug. We can give it to a support or a reliability support reliability customer engineer. And using procedures, we can minimize the downtime and leverage a decreased time to resolution depending on severity. For example, say we have a data pipeline that is taking CRM data in, and it is training a model on that, then creating a couple of dashboards, deploying that model, and then releasing those dashboards to sales staff, right? The model is used to make predictive leads, and the dashboards are then used by sales leaders to motivate, to encourage salesmen, to help with marketing. There's a variety of things that can be done with those. So we create an SLA for this CRM pipeline to make have the data be no less than and the model, the dashboards be 24 hours old. They cannot be any older than 24 hours. We take that and put that into revenue dashboard with minimal freshness of 1 day. We take that and we transport that into an SLO, right? An objective for our data service or our pipeline that is creating that dashboard. So we know that we want this pipeline to extract data from the CRM, complete its transforms, training, and analysis at least once a day. And if something happens, we want to be able to give us an error within a reasonable time, right? So that we can manually intervene and our SLA is never broken if something comes up and the automation fails. This allows us to keep that customer or the practitioner expectation without, compromise with some kind of a fall plan, while maintaining that reliability for our systems. So then we have SLIs, right? These are the indicators that alert us if we need to, as a reliability engineer, get involved. These can be errors if something happens in the pipeline, right? Maybe our model doesn't complete training. Maybe one of the transformations doesn't happen. Maybe we can't connect to the CRM. Maybe we time out and we are not able to write to our data store, or we are unable to, that timeout could be on the CRM or on the training. And these create alerts, right? These SLIs, if they indicate above your threshold, they create alerts and they allow that practitioner to know, oh, there needs to be a manual intervention to maintain that reliability standard that we have with our data practitioners or any of the stakeholders at the other end of our observability pipeline. So, great. Data reliability makes sense. It's transposing your normal reliability practices to data systems. Why do we need it, right? Great, the CRM stuff works, but what about more? That's not as critical as some of the other systems that rely on data we have. In one of my favorite books, Designing Data-Intensive Systems, it describes 3 types of data projects that all need data reliability to be infused into their project. The first one is your software data stack, right? So this would be, we'll get to it later, your software data stack, your enterprise data stack, and then of course your modern data stack. The software data stack, let's start. What is it? That is the data store for any customer-facing application, right? This could be a database to a microservice. This could be an in-memory cache. This could be any of your cookies stored in a browser, other kinds of application information, but any kind of data that interfaces directly with your software service. Typically, who manages this, the reliability of these data stores? This usually falls within the spectrum of site reliability engineers. They have tools they often come from operations backgrounds. They understand how to spin up databases. They have hosted databases, and they're not usually don't usually scale to the point where you need some kind of specialized knowledge for this kind of reliability interface. The enterprise data stack is quite a bit different than that software data stack. First thing first, it is your infrastructure or data platforms for enterprise data services. These are your large-scale distributed databases. These are your large data warehouses that are used for reporting and BI. These are SAP databases, Oracle databases, any kind of large data infrastructure that has grown into what various enterprise companies, large-scale enterprise services need. Who manages their reliability? That reliability for this requires a special set of data skills, and it is typically handled by your DBA or a database reliability engineer. Somebody who has that specialized database administration knowledge can do sharding, query optimization, has managed many flavors of database, SQL, or other custom database languages, but still would be the first line of defense if you have an error from your metric, reliability issue comes up. So now, what is this modern data stack? I mean, what's left? We've talked about software. We've talked about your large-scale data. What's left? These are any kind of pipeline and analytic that's used for machine learning. These are your ETL transformations that are used when you're extracting data for data scientists. Basically, anything that can be used for data, right? Creating data gateways, creating data mesh, creating custom machine learning pipelines on top of your data warehouse, perhaps, right? Where you're taking that data another step with extracting it from that warehouse and maintaining a pipeline. ETL pipelines that perform platform crucial transformations, right? Oftentimes, you're seeing it very common that information from your analytics data warehouse is being used in software applications. You're seeing machine learning models being shipped to production as part of the software product that is being maintained by back-end engineers. And they need somebody with more data expertise to come and step in and help maintain the reliability of those pipelines. And gateways that, like I mentioned, with something like your data mesh, where you have data gateways that protect golden data sets, but allow your data to be accessed by a variety of teams, of consumers, stakeholders, or other kind of data practitioner. And this is very different. This is not a data warehouse maintenance load. This is not a site reliability maintenance load. Who would manage this data set and make sure it stays reliable? This is what your data reliability engineer is trained to do. They have that skill set to understand what ingress and egress is, to understand ETL transformations, both in streaming and batch, to understand storage, varieties from, databases to large file stores, in-memory stores, distributed stores, basic data governance, and data analysis. They're not going to be your DBA and maybe be resharding databases, but they'll have a variety of skills that prepare them for handling data in motion as opposed to data at rest. They're going to focus on automating pipelines, automating services. They're going to be doing monitoring and observability on these data in motion systems and services, and they're going to understand modern architectures that are part of these systems, so that as they work with data engineers, they can create these contracts and SLAs that the practitioners need to maintain a quality of service. That is the data reliability engineer. I hope all of you understand the importance of it. I was on a team that data reliability became a central part of the work and the orchestration we were doing to provide our data practitioners with the data they needed to perform daily software tasks. It was very much fulfilling a contract, keeping your data fresh, not letting your data age out, keeping it viable, non-erroneous, and it can quickly go from something trivial to something that is very much a requirement for software services to run successfully. I think it is applicable to all data-centric services. Any service that relies on data to function needs to have some kind of data reliability in place. As data is democratized and used across the stack, we see this with movements like data mesh, where more and more teams need data, and they need a variety of data sets. And it's not just your analytics teams, it is software teams, it is operations teams, it is finance teams. And as this data is democratized across organizations, reliability in that data becomes more crucial to every step of that process, so that that nobody's getting calls because dashboards are outdated, but you can know in advance and have preemptive steps in place, like the SRE practices or handbook subscribes. And a data reliability engineer is specialized and different from any other reliability engineer because they work with data stacks and with data engineers, and they understand the data ecosystem, which is very different than a lot of software ecosystems. There are different kinds of optimizations and choices and design and architecture that need to be made. I want to thank you guys for coming to my talk. I hope you enjoyed it, and you can take away a desire to have maybe some new data reliability practices in your organization. If you have any questions about data reliability, where to get started, what to do, how to do it, please reach out to me. I'm available on Twitter, on LinkedIn. I do weekly Twitch streams. I'm happy to talk about that, brainstorm, and go further. I want to thank Conf42 again for allowing me to speak on this topic at this Site Reliability Engineering Conference, and I want to thank any sponsors, and most importantly, the attendees. And I hope to see you guys again next time.